Hi students, welcome you all for my next video in the experimental part of water supply and wastewater engineering laboratory. I am Dr. Prabhu, Assistant Professor, Department of Civil Engineering, Kongunadu College of Engineering and Technology. So let us have the experiment number 2 now. The experiment number 3 is determination of alkalinity and acidity. So let's see the laboratory part of doing this experiment. Okay, good morning students. Today in the next part of the video we are going to see the experiment acidity and alkalinity. So the required apparatus and the chemical reagents for this both experiment are concentrated NaOH 0.02 N and concentrated H2SO4 0.02 N and methyl orange as an indicator and phenolphthalein as an indicator. For acidity, we are bound to use NaOH as a burette solution, and for acidity H2SO4 as a burette solution. So right, already we are filled with NaOH in the burette and H2SO4 in the burette of the both side. And here we are going to take a sample of tap water or whatever the sample is required for your test, we can take down to identify acidity and alkalinity. So for acidity we use NaOH, for alkalinity we use H2SO4. And let's start with the experiment. Okay, so take a measuring jar to measure your sample. So already we have measured 25 ml of sample in conical flask and I have been dropped here. So first let us see the acidity, and already the NaOH is filled in this burette. So let us have a small shape to it. Let us see. Right, and the sample is filled of 25 ml in the conical flask and the solution of NaOH is filled with it. So right, the first step, let's add a methyl orange 1 to 2 drops for acidity. 1 and 2. Okay. Right. Let us shake. Okay. The color developed. So this color developed, which shows that there is no any other of mineral acidity. Okay. So let's note it down. My reading here is 0 and initial is 0 and final is 0 and consumed is 0. So hence there is no any mineral acidity while using methyl orange. Okay, right. So take it down the sample and take a new sample of 25 ml and now add phenolphthalein indicator. So 2 to 3 drops. Okay, and shake gently and titrate against NaOH. So before that, note it down the initial reading here and have some release of this burette solution so that the air formation can be avoided in the tube. And now we can have initial reading is around exactly, I think it is 0. Okay, let us titrate with this. So once you get off titrated with here, and it should end with the pink color. So let us have a titration. So yes, it is getting off pink. Yes, okay. Yeah, let us stop here. So here we can see the pink color has got changed. Right. Let us note it down, the reading. Yeah, it's around 0.3. Okay. Now the mineral acidity is 0, initial is 0, final is 0, and consumed is 0. And next, the acidity based on phenolphthalein indicator 0.3, 0.0, 0.0 is initial, and finally we got 0.3. And this is the final reading. So you repeat the same procedure to identify the acidity till you get a congruent value. Okay, so let us see the calculations. Okay. So the formula for acidity is normality of NaOH equivalent weight of CaCO3 into 1000 by volume of sample consumed. So around we get 3.6 milligram per liter. And you know the acidity is measured with milligram as CaCO3. Next, let us see determination of alkalinity. So alkalinity is the presence of water is due to hydroxide and carbonates and also bicarbonates majorly. So these are all the some of the components which makes your water alkalinity. Okay, so let us see the titration method of experimental for alkalinity. Okay, so as usual we have an burette solution is H2SO4 0.02 normality and phenolphthalein as indicator and methyl orange as an indicator. So as I have my sample is 25 ml of groundwater for measuring this, okay, and it has been filled with H2SO4 as a burette solution. So let us start here. Right. Let us start the titration part. Okay. So add two to 3 drops of phenolphthalein. So once you added, so there is no any change of color. And next add with so in the phenolphthalein there is no any change of color. If the color is got changed, you can have to titrate with this. So the phenolphthalein indicator we have 0 as a reading and we have methyl orange as 1 to 2 drops. Okay, so that you may get you can see gently you can shake, you can get a little yellow, there is a lightish yellow, and hence we can titrate with H2SO4 till it gets off orange or a dark yellow. Right, you can see a little an orange yellow is formed here. Okay, right, and let us see the readings. So the readings initially and final reading for phenolphthalein indicator is 0 and 0 and consumed is 0, and for alkalinity methyl orange, which is initial is 0 again and final we got is 7.2 around. So repeat the same procedure till you get a congruent value. And next apply this formula to identify, that is normality of H2SO4, that is given 0.02, equivalent weight of CaCO3, equivalent weight of CaCO3 is 42.7 and into 1000 and volume of sample consumed. The volume of sample consumed is 25 ml here. Right. And based on this calculation, we have identified that the bicarbonates and carbonates which is present in the water is around 42.7 milligram as CaCO3. CaCO3. Okay. So in this method, you can identify your alkalinity. Okay. So we are in the end of the session, so let me have some small notification to this. I mean a small intro to this. Okay, small intro to this. Okay, so we have been completed the 2 experiments here of acidity and also alkalinity. So alkalinity we use H2SO4 as a burette solution, and acidity we use NaOH as a burette solution. And as we know, the indicator phenolphthalein and methyl orange, and the both are has been noted in milligram per liter of CO3. So that's all, my friends. So let us have that we can see in the next video of next experiment in water supply and wastewater engineering laboratory. Thank you.